So this time we're going to write a program in TI Basic that's going to find some exact answers. So for example, on this Casio here, if you do the sine of 60 degrees, it gives us square root of 3 over 2. But on this fancy TI, sine of 60 degrees just gives us a decimal. So checking for possible fractional multipliers one by one is going to be slow and tedious. So to speed things up, we're going to use a matrix. So let's say we're going to have a 4 by 4 matrix of fractional possible multipliers, f. And I'm going to show you that as a fraction. So this is going to be our initial matrix f. So 1, 2, 3, 4 on the top row, and every row under it is just going to have the top value at that column divided by the row number. So row 2 is going to be 1, 2, 3, and 4 divided by 2. Row 3 is going to be divided by 3. And row 4 is going to be that divided by 4. Let's say our number n is pi divided by 3. So let's say we get this number back as a result of some calculation, but we don't know that it's pi over 3. So let's store our number as the number n. Take our number n, multiply by the matrix f, and we get back a matrix of what was originally all the values in the matrix f times our number n. And if we scroll over, you see that row 1, column 3 has pi. So to make it easier, let's divide all of this by pi and look where the matrix equals 1. So we can't divide a matrix by a number, so instead we have to multiply by a reciprocal. So let's do n times our matrix f, and then we're going to again multiply by 1 over pi. So now, if we scroll over, the third column of the first row equals 1. So we want to search our answer matrix where it's equal 1, and then we know what is the fractional multiple of pi. So I'm going to give you some code. It's going to run the same. You can follow along, including these older TI-83s here. I'm going to put the code up here. And for those of you following along on the TI-86, I'm also going to put the code up here. And you can pause the video and write the code. And we're also going to check for square root of 2 and square roots of 3, in addition to factors of pi. So we prompt the user for our number n, and here is where we store our fractional matrix f. That's going to keep our possible fractions. So here we multiply our value n times the matrix f, and we multiply by the reciprocal, and we store that as our matrix A. And now we simply loop over our matrix A, so 4 rows from 1 to 4, and inside that we have a second nested loop for columns from 1 to 4. And then we check if the value of matrix A at row R, column C, and we round it to 9-digit places because sometimes the internal precision is bigger than what the calculator shows. So if you don't round it, it's going to say it's not equal to 1. So we round it to 9 decimal places, and we then check if it's equal to 1. If it is, then we display pi times the fractional value of R over C converted to fraction. Then we stop the program. End statements to close the loops, and here we just do the same, except instead of checking for pi, we check for square root of 2. Same thing. If it's equal to 1, we stop and display square root of 2. And then we repeat the same thing for square root of 3. If it is, then we stop and display square root of 3 times the fraction. And here at the end, we just display the number n back to the user. That means we haven't found the solution. We just give him the original number back. So let's test it. So exact, what do we want? Well, let's do the sine of 60 degrees. And there you go. So it is the square root of 3 times half, which is the same thing that our Casio gave us. Let's test it again. Let's say we have a number of pi over 3. There it is. Now if you want to make our matrix of possible answers bigger, like an 8 by 8 matrix, you can also create that using a program. So let me show you that. So we start off with the basic identity matrix of 8 by 8. We store that as matrix B. And then we loop over each row, and inside that we loop over each column, and we store the column number divided by row number to our matrix B at row R, column C. So let's demonstrate that. It's done. Now we look at our matrix B, and let's look at that as a fraction. And there you go. So now we can have a numerator or a denominator of possible answers anywhere between 1 and 8. And if you want to paste this matrix into a program instead of typing it out by hand, you do second, recall, and you go to our matrix B, and look. Now our whole matrix B is pasted into the program, and we can just store it as a matrix name, let's say B, there. So now you put that in your program, and you can check fractional multipliers and divisors from 1 to 8. Except, of course, then you're going to modify the program. Instead of looping for 4 elements, you're going to modify the looping for 8 elements. So that's basically it. Like, comment, subscribe if you liked the video, and peace out.